Okay, let's look at a definition of a digital library. I use the acronym DL quite a bit because, after a while, the whole class is called digital libraries. We'll be saying it so often that it's nice to have a little shortcut. Here's a definition that a colleague at Indiana University uses for a digital library. Digital library is a network collection of digital objects. We use the term digital object in this course. That could be a text, so like a document, still images, moving images. We tend to think of film or video as moving images, sound, and data, which data can mean a lot. Data, in a sense, all these items could be considered data, but typically when we are enumerating these out, we think of data as like data sets. These could be text files or just sort of raw data. With arrangement and search features and metadata, that's a big term that we're going to talk about, that allow discovery and presentation, supporting research and teaching with attention paid to architecture. So this would be, basically the system that is put in, the persistence, that's the preservation or making it last over time, longevity. Those two terms are kind of similar. In digital preservation, I put all three of those kind of in the same basket, although they do have different meanings. So this is her definition. As we saw from the readings, we had some sort of different flavors or different angles of what digital libraries could be. Here's another one. This is from Wikipedia. Digital library is a special library. Okay, another term, one that sometimes could be kind of used in different contexts. This is being digital library is a special library with a focused collection of digital objects that can include text, visual material, again images, audio material, sound, video material, moving images stored in electronic media formats as opposed to print or microform or other media, along with the means for organizing, storing, retrieving the files and media contained in the library collection. Digital libraries can vary immensely in size and scope and can be maintained by individuals, organizations, or established physical library buildings. So again, a lot of similar terms. Some of them are a little different. We'll talk about electronic versus digital. That's a word that sometimes is a little bit of a term that I feel like is not that imprecise. That is electronic, and we'll talk about that later on. Here's another definition. Don Waters is a big name, or was a big name in digital libraries. You're not going to see him he's still working in the profession, but I wouldn't say he's publishing like he was. What he says is digital libraries are organizations that provide the resources, including the specialized staff, to select, structure, offer intellectual access to, interpret, distribute, preserve the integrity of, and ensure the persistence over time of collections of digital works, so that they are readily and economically available for use by a defined community or set of communities. I really like his definition. It's a little bit more abstract and kind of high level, but it definitely, it's so high level that it won't go out of date anytime soon, but he has a slightly different angle from it. This idea of communities or sets of communities, this was a term that at the time was kind of a new one, but now is pretty accepted. Digital works, instead of objects, he uses the word digital works. Again, sort of similar, sort of different. Sometimes the definitions are the same, but they kind of they have different connotations. Collections of digital works, okay, we can spell this out a little bit more. Collections of digital works are distinctions among libraries commonly focus on subject matter that define the collections. So you might have digital works that are medical in nature, art, could be a visual, like a slide library that's been digitized, science, here we go with like maybe a data set, or images, it could be almost anything, music, and so on and so forth. And then we have communities, and we'll talk a little bit about that all throughout the course, but what is your designated community? Well, as librarians, we always just say the general public, and that's an easy out, but a lot of times it's more specific than that. It might be a research community of a particular stripe or color. It could be a college, like an institution. Where I work in the archives and special collections, we do have a couple designated communities. One is the university, but we also have the general public as well. And so here we also have the public. Again, what is this digital library? What is its goal, focus? Who's its audience? You have aspects of a collection. We're still very high level. Many of these things we're going to drill into more deeply as the course moves on, but we might have a collection policy. In fact, we should have one if we're going to have a digital library, or any library should have a collection policy. What falls in the scope of what goes in the digital library? The collections are described in such a way or have metadata that's assigned to them that make it so they can be discovered. The resources are actively managed, so these collections that get put in a digital library are going to be updated. They're going to be managed in such a way that it's basically a living digital library. They're not something that you just put stuff in and walk away. They need to be actively managed. Intellectual rights and copyright and so forth, that's something that I don't talk a lot about in this course, but we will talk about it a couple different times. We could really spend a whole class, a couple weeks or even a whole course dealing with copyright and digital libraries, because it does get very tricky. But anyways, that's something you need to be concerned with. That it's interoperable, that's a term we'll talk about more when we get into metadata and preservation, but that basically means that like the metadata standards that you use, the file formats that we choose, that those all can interoperate among each other. And then systems that you use, can one system talk to the other one? That's what interoperable has to do with. That it integrates into the user's workflow. Okay, that's a little bit more specific, but basically that the digital collection that you use or the system you use, does it actually fit the institution's workflow that you use? And then is it sustainable? That's a very broad term, but basically, is there a financial sustainability associated with it? How are you going to fund it? And then is it technically sustainable? Are you using up-to-date formats, metadata standards, and so forth? All that stuff we're going to talk about throughout the whole course. So we're not going to get too into that right now. I break up digital libraries into basically three types. We have a standalone digital library. So that's kind of when I think of a digital library, I still think of a standalone one. This is a self-contained one. This is here where I work at Special Collections, we have a self-contained digital library. The software we use is called Luna, but basically it's just a digital asset management system. We have another one here that we collect it's called our institutional repository, and it collects a lot of the published journal articles and preprints and so forth by faculty across the university. That would be like a standalone digital library. A federated digital library is something a little bit different. That's a digital library where the digital library has objects in it, so it has all the digital stuff, but it's a federated one where digital objects are collected from various digital libraries and put into one using various technologies to do that. So you might be doing a federated search, and so you're pulling in digital objects from various digital libraries. So you could have an art library, a medical one, a music library, do a search, and you're going to be pulling in medical objects, potentially art objects, and music objects, for example. Harvested digital library is a little bit different, and we're going to get into this in a little bit more detail. In fact, I define them more, a slide for each one, but basically that's a distributed library where you're not going to have any actual objects in it. It's really just metadata records that are pointing you to various digital libraries. So let's move on. Okay, standalone digital library. This again is what I think of as like a typical digital library, usually installed on a web server. So, for example, I mentioned Luna, which is our digital asset management system, another name for a digital library. That's actually installed on a Windows server in the data center here at UAlbany. Self-contained, it could have born digital items in it. Scan, digitize, purchased. We have all three of those in there. We have born digital images and audio. We also have scanned or digitized materials, and we have some purchased images that we have in there as well. It could have single or several digital collections, and this one again happens to have multiple collections in it. Here's sort of a visualization of what a standalone digital library might look like. Here we have the user. These are a couple users. They want to go to a digital library. Well, they're going to go out on the web. They're on the internet here, and they're going to have, for each digital library, they're going to have a search and presentation screen that's going to be different for each digital library because they are really separate ones. Not unlike all the various collections I had you look at that are, I'll just pop over there real quick. These here, many of these are standoff, one-of-a-kind digital libraries. Here we have a college. It's kind of near where I grew up, so I thought I would put that in here. This is a digital library. Here's UAlbany's Luna. This is a digital library, completely different search interface. If I want to look up, you know, Love Canal, Buffalo, we don't have anything on it, but if I looked it up, nothing comes up. If I look up WAMC, our local radio affiliate, here we get various audio. Again, this is a standalone digital library. And you got to look at some of those. Federated Digital Library, again, is a little bit more complicated, a little different, contains many separate digital libraries, usually heterogeneous repositories, so that means that the federated digital library is going to have many different repositories, so just by their nature they're going to be diverse. It uses a search layer, a discovery layer. Federated search is kind of a term that's kind of fallen out of fashion. Now you have discovery layer, that's the one that's used a lot, but federated search is a little more specific, meaning that you're typically searching across many silos, if you will, or many digital libraries. Should go without saying, now it's connected via network, forms a virtual library. The user interface should be relatively transparent in the sense that you shouldn't be really knowing that you're searching all these different libraries. The interface should be very user-friendly. The one issue with creating a federated search is that interoperability really needs to be perfected in your federated digital library. So your metadata needs to crosswalk properly. Do the objects that show up in that federated digital library show up correctly? Those are all things that you would potentially have already taken care of, but they are issues you'd have to work through if you were to create a federated digital library. And here's an example where you have one search and presentation interface, one graphical user interface, but many digital libraries that you're searching. And harvested digital libraries, this is kind of, I would say, really the digital library of the 21st century. It harvests digital objects, so often the metadata that would go with the digital item and the digital item itself, but not full digital libraries. It's a little bit tricky how it does this, and each harvested digital library does it a little bit differently. But the objects are harvested into metadata using an Open Archives initiative. We'll talk about OAI later on when we get to metadata. But doesn't necessarily have to contain the objects. Sometimes it does, but often not. It'll just have the metadata and maybe some kind of thumbnail representation of this digital object that you've searched and you've retrieved, and some kind of summary of what the object is. Has a lot of the same characteristics of a typical digital library, but once you actually go to click on the object, say it's a Mark Twain novel that has come up, and like you're looking in the Digital Public Library of America, and some early manuscript of Huckleberry Finn pops up, and you can see the metadata for it. You can see perhaps even like a little thumbnail representation of it. When you actually click on that, you're going to be taken to whatever library, digital library, owns that. The DPLA, for example, does not actually house that on their servers. They house the metadata objects and all the references to the actual digital object, but they don't hold the digital objects themselves. So at least DPLA doesn't in this case. What that allows them to do is really focus on access and not necessarily focus on owning the objects, and there's a lot of stuff we can talk about with DPLA, but if you remember in one of the readings, the Nicholas Carr reading, that was one of the sort of drawbacks or misgivings, if you will, about calling this the Digital Public Library of America, particularly the library part, because really none of the objects are in that DPLA. They're held elsewhere. So it's kind of a little bit of a paradigm shift with how this digitized version of the Library of America is, but it's sort of the world we live in now with digital assets and digital objects. There's a lot of issues that go with like copyright and paying for the servers to hold all these, videos, audio, images, and so forth. So anyways, that's a harvested digital library. And here's a little map, kind of similar to our federated one. Again, same search and presentation, but when you get into the harvested digital library, you're still having to go out to each one of these digital libraries to actually get the object. Here's a breakdown. A single digital library or federated one, you're still dealing with purchase or digitized, or born digital items. It's kind of obvious it's going to be a networked or some kind of local setup. There's not too many local digital libraries. They're almost all on the internet or on World Wide Web. There's items and catalog data, so metadata plus the digital object. Repository size in terms of its data footprint would be large because you're actually holding the files themselves. So a metadata record, might be 1 kilobyte. It's tiny because you're just talking about, maybe 1,000 characters. But when you're dealing with, say, a 1-hour video, you're looking at potentially 12 gigabytes or more, depending on what type of file format's used and so forth. So very large. The update to that, a little bit more onerous because you are actually putting not only the metadata records but the physical objects into it, so the updates is a little slower. And interoperability is one of the ways it works, although a digital library could work without being interoperable. In some ways it has to be able to operate among itself, but it does not necessarily have to operate among other libraries, digital libraries. Federated, on the other hand, does, and we'll talk more as we move along in the class. And again, examples, a lot of college or university digital libraries, this would be a typical kind of profile for those. Again, DPLA is one of them. For harvested digital libraries, look at some of the characteristics. Again, gathered or /harvest I could put in there. The items or the digital libraries, they're scattered, so they're going to be disparate, geographically scattered, across the U.S. or across the world. You're really just looking at catalog material, again, metadata records that you're getting. The repository size, again, the data footprint is going to be quite small. Depending on the size, DPLA is still quite large, even though they're just metadata records they hold. You're still talking about lots of servers there because they're cataloging a lot of materials. Update is fast and dynamic because how they work is basically all these records are being pushed to them, so it's a fast, updated, dynamic sort of environment. And then the assumption is that it's all interoperable. That's the only way a harvested digital library could work. Another example of this, and really sort of a grandparent to the DPLA, is the OAI-STR or Oyster that was once at University of Michigan and then got moved to, and I think I have that on the on first week here. This is Oyster or OAI-STR. It's using the let's try this again. The OAI protocol for harvesting metadata records, and haven't been on here for a while. But yeah, so you can go in here. Let me try Love Canal again, see if something comes up. I didn't even try this search, but yeah. So it has a little bit of this stuff that we talked about, and with the As We May Think, recommender systems or autocomplete. This is some of the stuff that Vannevar Bush envisioned, and there it's happening. Okay, so basically what we're getting here is not the item itself, but we're basically getting metadata records that are going to refer me back to the library that owns it. I'm not going to get too much in this because I didn't actually do this search, but here this digital library or whoever owns this would be in Houston, Texas. So this is again is an example of a harvested digital library. Acquiring digital collections, we have sort of a digital acquisition continuum. We just talked about harvested digital libraries. Really what you're doing there is just linking. It's a very weak, small amount of responsibility for caring for the objects themselves. You're really pushing that care and custodial custodianship to the digital library, the university, whatever institution owns it. You're pushing that off to them. You're just merely linking. Mirroring could be your sort of replicating that digital library. Hosting is when you're getting actually, like we have Luna, where we hold the materials in a server that's in our institution, and then to archiving would be the long-term responsibility for it. And the further you go to the right, typically the more expensive it gets. It just depends on the size and scope. If we're talking about your vacation photographs, maybe not too expensive, but if you're talking about NSF grant data, or the scale that, say, the Library of Congress or DPLA, for that example, are working on, then you're talking about a lot of costs there. And then as you get more into this responsibility of owning the actual objects, you have all sorts of scanning, tape loading, format conversion. These are all the things that go with digitization that we're going to talk about later. Every digital library requires staffing. Towards the end of the course, we're going to have you do an assignment where you get to really envision what a staff person might look like and what staffing you would need. But for now, we're just talking about sort of at a cursory level what a digital library entails. So you're going to need designated titles. No longer it's a digital library, so it's no longer a conventional library. A lot of the same skills that we'll find will transfer from an analog library, if you will, to a digital library. But what's going to sustain this digital library? What staffing does it need? Is it grant funded? Do you need catalogers, metadata specialists, digital curator, systems librarian? These are all people who have roles that would play in running a digital library. Some of them might overlap. You might have one person that literally does everything for the digital library, or you might have a team of a dozen people. Again, it could be one whole designated unit that runs a digital library. It could be a blend of staff, cross departments, and we'll talk more about that as the course goes on. Types of materials, we've already mentioned that a little bit. Audio, video, books, images, and documents. Scientific materials, here we have data sets, which I just talked about briefly before, but raw image data. When you talk about like data from NASA, now of course I don't deal with this, and perhaps none of you might not ever work for NASA, but there are other places like hospitals that deal with a lot of raw image data, like in any place where they're doing MRI imaging. Those are huge servers that have to store those, because those MRIs are gigantic files that get created. GIS here at the state, state of New York has big GIS data sets. Those all have to be managed in some kind of digital library. Architecture, you'd have CAD, computer-aided design files, AutoCAD. These are materials that perhaps never would have gone on a bookshelf. Data sets and raw images, they wouldn't have been in a quote-unquote library, but now many of them have come under the jurisdiction of what a digital library might be. Even further out there, again, you could call this sort of scientific data. You have gene banks, phonology. We have a researcher who left our university but had collected a lot of basically people talking in languages that are endangered or have already gone into an extinction. A lot of Native American and Central American, South American languages. So all sorts of materials out there when you think of a digital library. We shouldn't just think of images and video and so forth. Born digital, that's a term maybe you've come across before. I'm sure you created a lot of born digital and didn't really think, oh, I just gave birth to a digital image. But born digital are basically resources and items created and managed in digital form, so that it never had an analog existence. It was always digital. It was always zeros and ones. So we have same thing: images, audio, documents, video, websites. These are other things we need to talk about. But when you snap a photo on your smartphone, that's a born digital. You just gave life to an image that never saw life in the analog world. It's all zeros and ones. Electronic records, that's a term that if any of you are in the archives track, you might see that term bounce around a little bit. It's kind of falling out of fashion because electronic, really, there's a lot of information that can be held electronically but not in zeros and ones, so I tend to prefer digital records, but electronic and digital are still pretty interchangeable. But when we think of electronic records, the definition, or digital records, is data or information that's been captured and fixed for storage and manipulation in an automated system that requires the use of a system to render it intelligible by a person. So again, that's sort of the definition of a digital record. It's very archivist oriented, this definition. Digitization, that's a term, again, if folks that are in the library track or archives track, you're going to come across this. If you're more just straight up information science or in the application development world, IT world, digitization is something you know what it means, but you probably haven't been around it. But this is basically the process of converting, images, anything in an analog format, into a digitized format, into bits or bytes and zeros and ones. And here's a little definition I pulled from the Society of American Archivists dictionary. It's the process of transforming analog material into binary, electronic, or digital form. Again, there's that electronic, especially for storage and use in a computer. So very generic term. And I should note, as kind of, I guess maybe not a disclaimer, but just to make you aware, a lot of my examples I use kind of come from the archives world because that's what I work. So a lot of my real world examples of digital libraries often have to do with archival materials. A lot of time typically digitized, not always. Some of them are born digital. But anyways, I will mention digitization quite a bit, and we will talk about it in several classes. So we have various ways of inquiring, like, for example, image formats, which we're going to talk about in depth in week 3 and 4, and I think 5 we're going to talk about images. So we have various formats. We're just going to talk, just on a very basic level here. We have high resolution TIFF formats. These are typically like an archival version or master version. We have online versions that we use. We have GIF, or sometimes they're pronounced GIF. We have JPEG. There's also JPEG 2000. And then we have high or medium resolution JPEG or TIFF. Up and coming ones are Mr. SID, FlashPix, and PNG. Those are ones that I know about but personally have not used too much. Mainly what I've used is TIFF, JPEG, and JPEG 2000 is one that is used. It's a, we'll talk about this more, is a compressed format but is lossless. These other ones, GIF and JPEG, when they're used in their conventional manner, are considered lossy. And again, here we have formats lossy and lossless. So lossy would be any type of vector image format where it's been compressed. Lossless typically means a raster format, but it can be a vector one. But it means it loses no, when you save it and move it through time, it loses none of its, basically its image quality. And then here's what it looks like when it's in your file system as a file format extension: JPEG, .jpeg, .tiff, .raw, and so forth. I didn't mention RAW up here, but we'll talk about that later in the class. But RAW is another high resolution, lossless file format. Scanners for digitizing, we have flatbed ones. Those tend to be a little cheaper, a little easier to use. High resolution, but very slow. When that head goes across the screen, it's a very slow process, but still used. We have one in the department that looks more or less just like this one. Overhead camera, this is often used with fragile items, typically a little more difficult to use because then you have to deal with lighting, and there's other issues. The camera itself can be a little more difficult to operate, and then typically there's a lot of handle with care that goes in with dealing with the object that you're scanning. I'm just going to talk about, we only have 2 more images or 2 more slides. I just want to talk about just kind of like a little bit of introduction to images before next week and just leave you with this. But you might think of digital images as electronic snapshots taken of a scene or scanned from documents such as photographs, manuscripts, printed text, and artwork. We've already talked about that a little bit. But a digital image is a sampled and is mapped as a grid of dots or picture elements or pixels, if you will. Each pixel is assigned a tonal value. It could be black and white or shades of gray or color. And then they're represented by a binary code. And then, you know, we're back to zeros and ones. But basically we have black and white or gray, shades of gray or color. And as you go from left to right here, the file size typically gets bigger. Binary digits or bits for each pixel is stored in a sequence of computer and often reduced to mathematical representation. That means it's been compressed. And the bits are then interpreted and read by the computer to produce an analog version of the display or printing. So here's an example of what a digital image. We have pixels. It's the smallest controllable element on a screen. You know, how many pixels, when you think about like your TV at home, how many pixels can it fit in a square inch? Basically, the image resolution, as I just said, is how many pixels can you fit in a square inch. The more pixels you have, the better the resolution, because in a square inch, if you only had, say, 1 pixel, well, that would be pretty obvious to see and be very low resolution. 2 by 2, here you can see them, and as it gets more and more pixels in a square inch, before you know it, you can't even see the pixels anymore, and that's where you get high resolution rendering of an image or video or whatever we're talking about. Grayscale is what I was talking about with gray. There's various levels of grayscale. Digital images may be produced in black and white. This is bitonal, and we'll talk about that more as the class goes on. Grayscale, which is typically 8-bit, and then there's color, which is 24-bit. And these settings can change, but these are sort of the standards as it's used today. And then here we can look at sort of the pixel values, if you will, with bitonal. That's where it's very easy for the computer to represent it, and hence a bitonal image is very small, because really you're just talking about, is it black or white? There is no in between. So that's kind of a way to think about, you know, a character H being represented. Okay, that does it for our week 2 presentation, and look for any other videos in this week 2.